How you doing, everybody? This is Len from GNL Labs, and what we're going to do today is I'm going to make a bracket for a kitchen drawer that has broken, and really this is a great way of understanding why every home should have access to a 3D printer. Whether you own one or not, or you use one, these are just, it's so helpful to have. What we have here is a simple kitchen bracket. My brother happened to, he's a little stronger than he thinks he is. He opened his drawer, broke the bracket, drawer came off the thing. He tried to do some repair work. Obviously that it didn't work. So what we're looking at now is we're just going to take some, what we have to do is we're going to replicate it basically. So I'm going to take some simple measurements here. I'm going to get this tape off. Now this is not a high precision item, so you know your measurements are going to be, you can have a little bit of tolerance, but you want to be as close as humanly possible. So I'm measuring it, and and if I can give a word of advice, when you're taking measurements like this, try to use millimeters, because they are just so much easier to use than trying to break down fractions. So we've got 31 millimeters wide there. He tried to find one of these online, but he couldn't find one that matched the dimensions. So here we are. So it's 31 millimeters wide, 51.2 millimeters long. Now I'm going to take the measurements of the walls. 3 millimeters wide. This one looks a little bit wider. 3 point, slip, sorry. 3.56. Now we're going to get the dimensions of the width of that little cutout there, which is 3.99 millimeters. Now you can see there's a little track right in there. I don't know, it's hard to, you can see right here, it goes from thicker to a little thinner, and this is the track where the actual drawer would run on. And so what we're going to do there is we're going to get the width of that as best we can, and we can get it, so it's a little 6.75 millimeters, and then I'm going to have to calculate out the width of that little gap right there. Well, that shouldn't be much of an issue. So basically, now that I have my dimensions, I'm going to copy them down off camera, because that's kind of dull to watch, and then I'm going to we're going to head over to Fusion, and we're going to get this thing drawn up. Alright, so we're over here in Fusion. I'm not going to bore you with a Fusion tutorial. What I went ahead and did is I've gone ahead and sketched the entire part so we can just look it over and I can show you what we did. You remember we took our dimensions, and what you do whenever you're doing a CAD design, what you do is you start off with a drawing, a sketch, and then you just make it from a two-dimensional drawing to a three-dimensional rendering is what you do. And you can see what we have here. You can see how this thing is going to work. It is going to be mounted to the back of the cabinet. A screw is going to go through this hole right here, and this is what it's going to mount it to the back of the inside of the cabinet. And then the bracket for on the side of the drawer itself is going to go into here, and this is going to keep it as a guide, and it's just going to go in and out. And as this is, when this is the closer to the back, obviously the drawer is closed. As it goes this way, the drawer will be opened. We can take some measurements, which we could verify against our previous drawing or our previous measurements from earlier. You can see how long. It's 56.5 millimeters long. We can check the width. You know, it's 3.1 millimeters. So we can, and then what we can do here is we can also get the thickness, which actually I didn't take that measurement on camera. I actually forgot to do it. What it was is you are going to, I needed to get the thickness of the wall here and then through the groove, so I knew how far to extrude the groove in. So, you know, on this side, it was, it's 2.5 millimeters thick at the thick point. And then the extruded portion is going to be a little thinner at 2 meters even. So it was actually exactly a 0.5 millimeter in depth. and you can see, and when you see it on the actual part, everything looks really magnified when you're looking at anything on a CAD drawing, particularly if you're ever doing anything with text or anything with a photo. It looks huge on here, and then you got to remember you're dealing in millimeters, not inches, for the most part. I mean, here in America, we deal with the empirical system, which is of course inches. And here's something to think about. There's 25.4 millimeters per inch. So for me, this is it looks like a huge thing on here, but it was 56 millimeters long, which is what, just over two inches from top to bottom. That's all it is. You know, that's the thing you have to kind of remember too. Sometimes it's easy to lose perspective on what you're drawing or designing when you look at something, when you're looking at a CAD design, because again, you know what the measurement should be. But like if I was to put, say, some sort of a text here or something, you know, like this side up, you know, if I was to do that, it would it starts off with like a 10 millimeter high letter, which looks huge on most drawings if you're doing a small part, and then you take it down to like say 4 or 5 millimeters, which is not very legible. It's hard to read. So that said, I went off. Now you heard my little tangent on, you know, making sure you scale everything. And also, whenever, again, I mentioned it before, when you're taking measurements or whenever you're doing any kind of measuring for CAD drawing or any kind of measuring for whatever kind of project you're doing, you'll find it is much easier to work in, you know, millimeters in the metric system as opposed to the empirical system of inches and feet, because you got to remember we deal with fractions of an inch, you know, sixteenths of an inch, as opposed to, you know, centimeters or millimeters. You just count the millimeters, and you're dealing in whole numbers for the most part. And you got to remember everything is functions, and you know, everything. The base is a meter, so you have 1,000 millimeters in a meter, 100 centimeters in a meter. And then, you know, there's 1,000 meters in a kilometer. It's very easy to follow. I mean, what we do here is the way we do our measuring here is actually not the most optimum way to do it. We're the only country, I believe, in the world that uses the empirical system. Everywhere else, and if you're ever doing any kind of work in science, you know, engineers and physics, they all use the metric system. But anyways, quick recap. The screw is going to go through this hole. Then after it's mounted to the back, the bracket for the drawer is going to fit into here. Now this could be reversed if the bracket on the other side broke, but I'll probably run off a couple of them, just so, you know, he's got a couple extras in case, you know, he hulks up and breaks another. But that's about all I got. Okay, so we've got the program we have the STL file all loaded up. We put it through the slicer. Now we're starting to print. I'm not going to stand here like this for the next few hours, so I'm going to come back when this is done and we'll check out how it came out. Okay, so we have the final piece off the printer now. I took the liberty of not making you watch me get all the support materials off. You can see where it's sat on the print bed. I didn't use a brim because it's not going to be a piece you ever look at, so I wasn't overly concerned with the cosmetics. But as you can see there, you can see it needs to be sanded, but I'm probably not even going to bother. It's just going to get mounted. You're not going to see it anyway. So let's do a side-by-side comparison. Here's the actual broken clip, and here is the remade. It looks pretty good. It looks like the channel I have here, the screw mount channel there is a little longer, but nothing catastrophic. You can see they are similar in height. It's a bad choice of sides. There you go. And now the channel that we discussed earlier in the Fusion video, you can see it there. You can see and what it is this is to keep the roller on the side of the mounting bracket on the drawer, to just keep it in line. And what this does, this is a screw goes into there, and this is what mounts it to the back, so it's going to be mounted like this, and then the drawer will just slide in and out of here. So it looks like size wise, thickness wise, we're in the ballpark. This looks like it's going to work this looks like it's pretty easy. I'm going to install it, and then we will see how we did, and that's about it. Alright, as you can see, we finally got the bracket installed. The rail is sitting securely. It mounted with no issues. You can see it's a little different in color than the other, but obviously you can't see that when the draw's in. So what we did here today is we took a broken part, we replicated it, we fabricated it with a 3D printer, and that's what we do here at G&L Labs. So thank you. Have a good day.